before T-Rex walked the earth, before the first dinosaur took its breath, before flowers bloomed across ancient plains, before the continents even recognized each other, this animal already existed, crawling, feeding, surviving. Meet the horseshoe crab, a creature so ancient, so impossibly enduring, that 450 million years later, it is still here. Still moving through the same oceans, still following the same instincts, still alive. While dinosaurs crumbled into fossils, while megalodons sank into extinction, while thousands upon thousands of species vanished without a single trace, this creature remained, unchanged, unbothered, unstoppable. So the question that should be burning in your mind right now is not how old this animal is. The question is far more unsettling than that. The question is why? Why did this creature survive when everything else around it perished? What secret does it carry inside that ancient shell? And what does its survival tell us about life itself? Because this is not just a story about an old animal. This is a story about the greatest survival mystery on the planet. Imagine stepping into a time machine and traveling backward, past human civilizations, past the rise of mammals, past the great woolly mammoths roaming frozen tundras, past the age of reptiles, past the towering forests of the Carboniferous period, further and further back through hundreds of millions of years of Earth's violent, chaotic history, and eventually at the very bottom of that long and brutal timeline, you would find this animal, the horseshoe crab, almost completely unchanged from the version crawling across ocean floors today. The same domed shell, the same long tail spike, the same slow, deliberate movement through shallow coastal waters. Scientists call animals like this living fossils, creatures whose bodies stopped evolving dramatically because they already found a design that worked, a blueprint so effective that nature saw no reason to change it. But here is where the mystery deepens. Surviving millions of years in a stable environment is one thing. Any well-adapted creature can manage that given enough time and the right conditions. But surviving mass extinction events, surviving the complete collapse of entire ecosystems, surviving the kind of planetary catastrophes that reset life on Earth entirely, that is something else. That is something that demands a real explanation. 66 million years ago, a rock roughly 10 kilometers wide, traveling at approximately 20 kilometers per second, slammed into what is now the Yucatan Peninsula in Mexico. The impact released energy billions of times more powerful than the largest nuclear weapon ever detonated. The sky turned black, temperatures plummeted, forests burned across entire continents, oceans became acidic, the food chain collapsed from the bottom up. 75% of all species on Earth disappeared. The dinosaurs, creatures that had dominated this planet for over 160 million years, were gone. Wiped out in geological terms almost instantly. Most large animals never recovered. The world that existed before that asteroid was fundamentally different from the world that came after it. And yet crawling through the chaos, surviving the darkness and the cold and the collapse of everything around it, was the horseshoe crab. It endured, it persisted, it continued. But here is the detail that makes this survival even more extraordinary. The asteroid impact 66 million years ago was not the first extinction event the horseshoe crab survived. Not even close. This creature has outlasted catastrophes that make the dinosaur extinction look almost minor by comparison. Scientists have identified at least 5 major mass extinction events throughout Earth's history. The most devastating of these, known as the Permian-Triassic extinction event, occurred approximately 252 million years ago. It wiped out an estimated 96% of all marine species and 70% of all terrestrial vertebrate species. The oceans essentially died. Life on Earth came closer to complete annihilation during that event than at any other point in the planet's 4.5 billion year history. And the horseshoe crab survived it. It also survived the late Devonian extinction, the Triassic, Jurassic extinction, event after event that erased entire branches of the tree of life. And this creature simply continued. So what makes them different? What biological advantage does the horseshoe crab possess that allowed it to endure catastrophes that eliminated creatures far larger, far more complex, and seemingly far more powerful? Scientists have spent decades studying this question, and the answer, when it finally begins to emerge, is both surprising and deeply fascinating. It starts with something deceptively simple, where they choose to live and how little they actually need to survive. Horseshoe crabs live along coastal environments, shallow waters, sandy ocean floors, tidal zones where land meets sea. They have no claws designed for combat, no giant teeth for hunting large prey, no venom to defend against predators. By almost every measure of what we traditionally associate with survival strength, the horseshoe crab appears completely unremarkable. And yet that simplicity may be the very core of their extraordinary endurance. They feed on worms, mollusks, and algae, food sources that exist in virtually every marine environment on Earth. They can tolerate significant variations in water temperature and salinity. They can survive in low-oxygen environments that would kill most other marine creatures. Their immune system is ancient and brutally effective. Their reproductive strategy is straightforward but prolific. They gather in massive numbers along beaches during spawning season, laying thousands of eggs at a time. When the world changes around them, they do not need to dramatically adapt because their needs are already minimal. They require very little to survive, and when you require very little can take you down. But as remarkable as all of this is, there is one aspect of the horseshoe crab's biology that elevates it from fascinating to genuinely extraordinary. Something inside its body that no one expected, something that would eventually change the course of modern medicine. Human blood is red. The red color comes from hemoglobin, an iron-based protein that carries oxygen through the bloodstream. But horseshoe crab blood is blue. Vivid, striking, unmistakably blue. The color comes from hemocyanin, a copper-based molecule that performs the same oxygen-carrying function as hemoglobin, but produces an entirely different color when exposed to oxygen. That alone is remarkable enough. But the color is not what makes horseshoe crab blood one of the most scientifically valuable substances on the planet. Inside that blue blood is a compound called limulus amoebocyte lysate, commonly referred to by scientists as LAL. This compound has an extraordinary ability. It reacts almost instantly to the presence of bacterial endotoxins, dangerous contaminants that can cause severe illness and death in humans if they enter the bloodstream through medical equipment or injectable medications. The reaction is so sensitive, so precise, and so reliable that it became the global standard for testing the safety of vaccines, surgical instruments, intravenous drugs, and medical implants. Every single injectable medication approved for human use is tested using a process that depends on this ancient creature's blood. The horseshoe crab, older than every dinosaur that ever lived, became an irreplaceable guardian of human health. Inside modern pharmaceutical laboratories, scientists carefully harvest blue blood from horseshoe crabs collected along the Atlantic coastline. The process involves extracting a portion of blood from each crab before returning them to the ocean. The extracted blood is then processed to isolate the LAL compound, which is used to manufacture testing kits distributed to medical facilities worldwide. Without this process, detecting dangerous bacterial contamination in medical products would be significantly more difficult, slower, and less reliable. The horseshoe crab's contribution to human medicine is not theoretical or historical. It is active, ongoing, and happening right now. Every time someone receives a vaccine, undergoes surgery with sterilized instruments, or receives an intravenous medication, the safety of that procedure has been verified using a method that traces directly back to this 450-million-year-old creature. An animal that watched the dinosaurs rise and fall, an animal that survived 5 mass extinctions, an animal that evolution essentially declared perfect and left alone. That animal is helping keep human beings alive in the 21st century. But the story does not end there, because for the first time in 450 million years, the horseshoe crab faces a threat it was never designed to survive. For hundreds of millions of years, horseshoe crabs survived everything nature could produce: asteroid impacts, volcanic winters, collapsing food chains, rising and falling sea levels, shifting continents. They endured it all because nature, however brutal, operates on time scales that allow adaptation. But the threats facing horseshoe crabs today are arriving faster than any natural catastrophe in their long history. Coastal development is destroying the sandy beaches where they spawn. Pollution is degrading the shallow water habitats they depend on. Overharvesting for use as bait in commercial fishing industries has reduced populations significantly along the Atlantic coast. And the medical harvesting process, despite efforts to return crabs to the ocean, results in mortality rates that concern conservation scientists. The creature that outlasted every mass extinction in Earth's history is now listed as a species of concern, not because of an asteroid, not because of a volcanic eruption, but because of us, because of human activity operating at a pace and scale that even the most resilient survivor on the planet struggles to absorb. And even nature's greatest survivor has limits. If the horseshoe crab survived 450 million years of Earth's most violent transformations, the question now is whether it can survive the next 100, whether it can endure the one force it never encountered during all those millions of years of persistence. The answer to that question is not written yet. It depends on decisions being made right now. Conservation efforts along the Atlantic coast are working to protect spawning beaches and regulate harvesting. Synthetic alternatives to LAL are being developed in laboratories, which could eventually reduce the medical industry's dependence on live horseshoe crabs. Monitoring programs are tracking population numbers and health across multiple regions. But the outcome remains uncertain, because even legends can disappear. Even the most perfectly designed survivors can be pushed past the point of recovery if the pressure is relentless enough and arrives fast enough. The horseshoe crab has earned its place in Earth's story through 450 million years of quiet, stubborn, extraordinary endurance. Whether we allow that story to continue is entirely up to us. Before dinosaurs walked this Earth, it was here, crawling through ancient oceans that no human eye ever witnessed, surviving in a world so different from our own that it would be almost unrecognizable. When the asteroid struck and the sky went dark and the dinosaurs fell, it remained. When civilizations rose and collapsed and rose again, it continued its slow migration along coastlines that were once the edges of entirely different continents. And now in this moment, while you watch this, somewhere along a moonlit beach, a horseshoe crab is pulling itself through the surf. Following the same instinct it has followed for 450 million years, laying eggs in the same sand, returning to the same ocean, carrying inside its ancient body a blue blood that saves human lives and a survival story that humbles every assumption we have ever made about strength, adaptation, and endurance. Long after we are gone, if we are wise enough to protect what we have inherited, this creature may still be crawling across Earth's oceans, still surviving, still ancient, still here, the ultimate survivor.